In 2010, India and Russia launched the fifth-generation fighter aircraft, FGFA, program under an agreement involving Sukhoi Design Bureau, Rosoboronexport, and Hindustan Aeronautics Limited. The project envisioned a twin-seat derivative of the Su-57 tailored to India's requirements, with both countries contributing approximately $295 million each toward the preliminary design phase. However, after years of concerns over the aircraft's performance, technology transfer, and overall capability, India exited the program in 2018. Speculation resurfaced recently that New Delhi might reconsider the Su-57 to help offset the Indian Air Force's declining fighter squadron strength and provide a counterbalance to China's growing fleet of J-20 stealth fighters. Those reports, however, have now been effectively dismissed. India's Defense Secretary Rajesh Kumar Singh made it clear in late July that the government has no plans to procure new Sukhoi fighter variants, signaling that the focus will instead remain on upgrading the Indian Air Force's Su-30 MKI fleet. Singh said when asked about acquiring new Sukhoi fighters, "No, we have not thought about Sukhois." He added that India was actively looking at upgrading the existing Sukhois, which we have been producing under license from the Russians. The remarks represent a notable shift from Singh's position in March 2026, when he said the government had not yet reached a final decision on competing fighter proposals from Russia, the United States, and France. His latest comments indicate that the Su-57 is no longer under serious consideration in the near term. For Russia, the decision is another setback in the Su-57's export campaign. Despite repeated public backing from President Vladimir Putin, the aircraft has struggled to secure international buyers. In this video, Defense Updates analyzes why India has shut the door on potential acquisition of Russian Su-57. Before we proceed, a word on NordVPN, which is one of the most trusted and fastest VPN brand that has a no-log policy validated by Deloitte. NordVPN provides a 256-bit encrypted tunnel that protects your privacy and also enables you to access contents that are blocked based on geolocation. Its threat protection system helps you avoid phishing, scams, and malware. NordVPN application is available for all the major platforms as well as browsers. Get an exclusive NordVPN deal with massive saving by going to nordvpn.com/defense or clicking the link in the description. It's risk-free with Nord's 30-day money-back guarantee. According to several published estimates, the Su-57's radar cross-section, RCS, is around 0.05 square meters. If accurate, that would make the aircraft roughly 500 times more detectable on radar than the F-22 Raptor, whose often cited frontal RCS is around 0.0001 square meters, and at least an order of magnitude larger than commonly cited estimates for the F-35. Criticism of the Su-57's low observable characteristics has also come from within Russia. Russian military commentator Vladimir Tushkov has argued that the aircraft falls short of the stealth standards typically associated with fifth-generation fighters. He has pointed to the exposed engine nozzles, which are not deeply blended into the airframe and can increase radar reflections, as well as the comparatively limited use of composite materials. Both factors that he believes reduce the aircraft's overall survivability against modern air defense networks. A similar assessment has been offered by Russian defense analyst Alexei Ram, who has stated that the Su-57 does not incorporate the same level of stealth optimization seen in aircraft such as the F-22 Raptor. According to Ram, the Su-57's larger radar signature makes it more susceptible to detection and tracking by advanced radar systems than its American counterparts. Despite entering service, the Su-57 has yet to reach the level of maturity expected of a fully developed fifth-generation fighter. One of its most significant limitations is propulsion. Most operational aircraft are still powered by the Saturn A L41F1 turbofan, an interim engine that falls short of the Russian Air Force's original performance goals. In this configuration, the Su-57 does not fully achieve sustained supercruise, the ability to maintain supersonic flight without relying on fuel-intensive afterburners. The long-delayed AL-51F1 Delhi A-30 engine is intended to resolve many of these deficiencies. It promises greater thrust, improved fuel economy, a lower infrared signature, and significantly better supercruise performance. Although Russian officials have stated that the first Su-57s equipped with the new engine have begun entering service, the overwhelming majority of aircraft delivered so far continue to fly with the older AL-41F1. This suggests that full-rate production and fleet-wide integration of the new power plant remains some distance away. The engine is only one part of a broader challenge. Russia is also working to refine the Su-57's mission systems, sensor fusion architecture, software, and overall systems integration, areas that are critical to the effectiveness of any fifth-generation combat aircraft. Compounding these technical hurdles are international sanctions, which have significantly constrained Russia's access to advanced Western microelectronics and avionics. Those components had previously found their way into a number of Russian military aerospace programs, and replacing them with domestically produced alternatives has proven both difficult and time-consuming. Production numbers further illustrate the program's slow progress. To date, only about 30 Su-57s have reportedly been built, and roughly one-third of those are prototype or test aircraft, leaving the operational fleet relatively small for an aircraft that has been under development for well over a decade. The Su-57 program recently suffered a setback with the reported loss of an aircraft in a crash. If confirmed, the accident would mark the second known non-combat loss of Russia's premier fifth-generation fighter. Although two aircraft may not seem significant in isolation, the figure is more notable when measured against the small size of the fleet. The loss represents roughly 6% of all aircraft built, highlighting that significant work may still be required before the platform reaches full operational maturity and reliability. India has relied on Russian military equipment for decades, with Moscow supplying a substantial portion of the country's fighter aircraft, armored vehicles, and naval systems. However, the experience with several major Russian platforms has raised serious concerns about reliability, maintenance, and long-term operational performance. One of the most prominent examples is the MiG-29K, the Indian Navy's carrier-based multi-role fighter. In its 2016 audit, the Comptroller and Auditor General, CAG of India, concluded that the aircraft was plagued by persistent technical issues involving its airframe, RD-33MK engines, and fly-by-wire flight control system. The audit revealed that by September 2014, India had procured 65 engines, 42 installed on 21 aircraft, and 23 held as spares. Yet after the fleet entered service in February 2010, 40 of those engines, or approximately 62% of the total inventory, had to be withdrawn from service or rejected because of design-related defects and deficiencies. The CAG also warned that these shortcomings had direct implications for flight safety, noting that engine failures in flight had resulted in 10 single-engine emergency landings. Fleet readiness was equally concerning. Between 2014 and 2016, the operational availability of the MiG-29K fleet ranged from 15.93% to 37.63%, while the two-seat MiG-29 KUB trainers recorded availability rates of only 21.20% to 47.14%. India's subsequent selection of the French-built Rafale marked a significant shift in procurement strategy. Beyond meeting an immediate operational requirement, the acquisition reflected New Delhi's broader effort to diversify its sources of military hardware and reduce its long-standing dependence on Russian suppliers. The Su-57's internal weapons arrangement consists of two large tandem main weapon bays located along the center line of the fuselage, each measuring roughly 4.4 meters in length and 0.9 meters in width, supplemented by two smaller side weapon bays positioned near the wing roots. This layout is designed to allow the aircraft to carry a substantial weapons load while preserving its low observable characteristics. To fully exploit this configuration, the Su-57 is intended to field an entirely new generation of air-to-air missiles. Among the planned weapons is the KMD Isdeliye 300, a next-generation missile expected to succeed the R-74M2 in the short to medium-range air combat role. For long-range engagements, Russia is developing the Izdelia 810, an advanced derivative of the R-37M, designed to engage high-value and distant aerial targets at significantly extended ranges. However, these weapons are yet to be operational. Much of the Su-57's intended future armament remains in the development and testing phase, meaning the aircraft has not yet realized the full combat capability envisioned when the program was launched. The war in Ukraine has significantly affected international perceptions of Russian military technology, with several of Moscow's flagship weapon systems performing below pre-war expectations. The Su-35, one of Russia's most advanced fourth-generation fighters, has been a notable example. Introduced into operational service in 2014, the aircraft was expected to overcome the shortcomings exposed during the 2008 Russia-Georgia War, when Russian aviation suffered unexpected losses to relatively dated air defense systems. After years of modernization, the Su-35 was widely viewed as a platform capable of operating effectively against legacy Soviet-designed surface-to-air missile networks. Events in Ukraine have challenged that assumption. Multiple Su-35 fighters have reportedly been lost to Ukrainian air defenses, including older Soviet-era SAM systems that Russia was expected to suppress or evade. These losses have raised questions about the aircraft's survivability in modern, highly contested airspace. The Su-57's operational employment has been even more revealing. As Russia's only fifth-generation stealth fighter, it was expected to lead high-risk penetration missions, dismantle sophisticated air defense networks, and secure air superiority over heavily defended areas. Instead, the aircraft has played a far more limited role. Rather than routinely operating deep inside Ukrainian-controlled airspace, the Su-57 has generally remained within Russian territory or near the front line, launching long-range standoff weapons from relatively safe distances. While this approach reduces the risk of losing one of Russia's scarce fifth-generation fighters, it also suggests that Russian planners have been reluctant to expose the aircraft to Ukraine's layered air defense network. Such cautious employment has inevitably fueled questions on Moscow's confidence in its most advanced combat aircraft.